Hello everybody. My name is Joost Koekarts. I'm from the Aurora Vehicle Association, maybe also known as the Aurora Solar Team. Um, I will be talking about just briefly about how to, well, not how to design, but the challenges of designing a solar car to be ADR compliant. And ADR is the Australian design rules. I'm not sure if everybody is familiar with car design. I've seen a lot of electric bikes around here. They don't need ADR, I think. But we are working on a solar car, which we plan to have ADR compliant, which would therefore mean that it would be the first solar car which is officially road legal in Australia, and I think outside Australia as well. But I might have seen some other solar cars which drive somewhere, but maybe they have special permissions. Anyway, we will. The plan is that we will design a solar car which has an Australian license plate, so you can just drive it as any regular car. So I'm actually not a legal advisor, because ADR is very legal things, a lot of text in these documents. I'm a senior electrical team member, so my task in the team is mainly the electrical design of the new car. However, I am quite an organized person, and they asked me to take a look at these regulations, and I've been looking at them. So that's why I thought in the trend of the EV community, maybe you might be interested what we come across. So in solar team terms, I'm actually well, according to international teams, they change their solar team member base every 2 years. Every 2 years, there's a new World Solar Challenge. You might know the World Solar Challenge from Darwin to Adelaide. The next one will be in October this year. I've been the founder of the Solar Team Twente, which is a Dutch team, not the Dutch team that wins every time. So unfortunately, but that was in 2005, and since then they have changed the team every 2 years. So 2007 was a new team, 2009 was a new team, and 11 a new team. Now they have another one. In Aurora, it's different. Aurora is not a university-organized team. It's not linked to a university. It is basically, you could see it as a car club of enthusiasts who like to build energy-efficient cars. So many of these team members have been there for a long time, some even a very long time. Some of them have been there since the first race, which was in 1987. So that's quite a long time. I'm only there since 2011, and I'm sort of the newest team member. But I'm quite active because I really like the solar cars. I mean, if you start a solar team somewhere else in the world, I mean, that's pretty much a sign that you like to do it. I already mentioned that I did the electrical design in this new car, but my backgrounds are also electrical, computer science, geography. I did a lot of things. I'm at the moment a PhD candidate at the University of Melbourne, and I'm the international director of NPO Solis, which is a company doing sensor systems. So it's not something that the team is really a volunteer thing all in your free time. The student teams do this all full time for these 2 years. So you have to think about the differences, like how we can deal with all these the challenges of mixing our current work with making a solar car. And then now the additional challenge of creating a car which is ADR compliant, because most of these cars follow just the Solar Challenge regulation. Now we need even bigger regulations. So, and maybe you've seen from my background already, I'm now a student, I'm international director. We have other team members, volunteers who are engineers, teachers, tradesmen, and, well, basically enthusiasts. Anybody who is interested in joining and working on a solar car can actually join. If you're medical, well, doesn't matter to us. If you want to learn how to lay up carbon fiber, no problem. So that's our team basically, and we've been active, like I said, for quite a long time already. The first World Solar Challenge was in 1987, and we participated in there with a car we called now Christine. At that time it was Ford Model S. Ford was a sponsor in that time. In 1991 we built a new car, Q1. both of these cars, almost all the cars we have here are still in our workshop. Christine has been refurbished and actually is now in drivable condition again. It participated in 2011 in the Solar Challenge. I think it was 2009, sorry, because of that was the 20th anniversary. Q1 is in need of restoration, but we have everything. Then we have Southern Aurora, which was built in 1996. That was formerly the Aurora RMIT 101. So at that time we had a collaboration with RMIT. And the current car, which is parked outside, is the Aurora Evolution, also called the Aurora 101, which was built in 2007. So now we're working on a new project. And this project is a more user-friendly solar car. So the idea behind this is that this car, if in production, somebody might actually want to purchase it, and somebody might just jump in and be able to drive it. That's the idea behind it. So it needs to be ADR compliant due to the license for the license plate and everything what a normal car might have. Well, maybe except air conditioning, because that uses just too much power. That will be implemented in this car. But it will still be, it's sort of a race car, a Tesla with solar panels maybe, but better aerodynamics. Similar price probably though. So to talk a little bit, I can talk a lot about all the things which are going to be designed. I mean, you can ask me questions later. I mean, I have limited time in presentation, I think. So I thought it would be interesting to just let you know what we're going through as a volunteer team who never really worked on ADR compliance in checking or making a car or designing a car to be ADR compliant. So according to the Australian design rules, first we looked at individually constructed vehicles to get a license plate on this car. It basically mentions the ICV regulations basically say you're making a new car, so your car needs to follow the Australian design rules. The ICV is the ICV regulations are mainly focused on the changing of a current car, or actually making your own car. I'm mixing up two different regulations. The bottom of the vehicle standards bulletin is for modifying your car from normal to electric. It basically has to follow all the requirements. The interesting thing what I found about the Australian design rules is that there's hardly anything in it about electric drive. It does refer to the United Nations standard on electric vehicles, which is this one I mentioned here. And it links to the vehicle standards bulletin for modifying a car, also states some information about how to make an electric car. So that's already, well, an issue maybe. The ADR itself doesn't say it, but it says, okay, look at this United Nations regulation. And well, all these ADR documents, of course, like thousands of pages, which is not really that easy. So how do we approach that as a volunteer team? Well, are we going to look at all those thousands of pages? Maybe a little bit, just select through. Like the second part, like we just select the type of regulations which we certainly know that they are applicable to us. I mean, it's an electric car, so we'll not have emissions, so we can just skip the whole emissions document. I mean, no petrol engine, no gas checking needed. Still, it's quite complicated, but we have contacts. We can use experts and their knowledge. We have some people in our team have been building individually constructed vehicles before, so we can use their knowledge. And of course, we can also take a look at what do current cars have, and well, we need that too. I mean, we're building a car. Just copy what is, it's not really copy, of course, but take a look what they have, redesign it for this purpose, and then continue. And look at the specific EV regulations, such as the United Nations document. So to go into the specifics for the electric vehicle specification, these things are taken, I thought were very interested maybe for you to know. These are taken from the United Nations regulations and the the Vehicle Standards Bulletin. And I think it's also applicable to if you want to use these things in your individually constructed vehicle or your modified vehicle. And there's some quite interesting things we found out. That you can find some standard situations, like you have your battery has to be impact resistance, 20G front, 15G side, 10G rear, 10G rollover. So if the battery should be able to withstand that. An interesting one is, which maybe the vehicles don't really implement, I'm not sure, maybe it's hidden somewhere, is an impact sensing switch. So if you have an impact, there should be a switch which immediately turns off your battery. I'm not sure if the modified vehicles outside have something like that. Haven't been able to ask them, but that's an interesting thing to take a look at. The solar cars normally don't have anything like that. Additionally, it needs to be a water-resistant housing. And that's very interesting because, I mean, our solar car itself can stand in the rain and there will be nothing in there, but the battery pack itself is quite simple. It has Velcro on it to take the batteries out because we need to maintain the batteries. So that's definitely not a water-resistant housing. So that's something we have to take a look at. Then to continue, the regulations say that, well, besides the voltage, you actually have to have a battery chemistry hazard label. The ADR states that. Well, the voltage label is well, pretty clear. I've seen them on other cars or here ahead as well. Over current protection, such as a fuse, is pretty standard. But then going towards battery management, you need to monitor all the voltages of each individual parallel cell group and the temperature of each parallel cell group. We certainly have to do this. This is not what we currently do. We use lithium polymer in our solar car, and also the new solar car we will use this. So the voltage is already being monitored, but we basically monitor the whole temperature of the whole pack, but the regulations state that we have to do each one individually. Then things you might not think of directly. All the cables, which if you think like a battery has a plus and a minus, you want to, okay, make it red and black. It actually should be orange. Black should the minus should be orange. The positive should be orange as well. And any component should have a cover which can only be removed with a tool. Like I said, we have Velcro cover because we need to access it very easily. We have to change something like this. Then even if you have this battery system, we thought, okay, we have a very big battery, we just do a DC converter to maybe 12 volt to run on the lights, but we have to actually have an auxiliary system just in case there's a battery failure. So another addition we need to take a look at. So other even specific items for the electric vehicles is, of course, that you if your car is in forward setting, you're not allowed to be able to put the button into reverse. I've worked in the solar cars before where you can actually just do that. You're driving in front and you flick the switch and the engine is in reverse. Well, that should, of course, not really happen. I mean, if you're designing these prototypes for racing only, everybody knows that you should not do this. But if you're going into the direction of making a car for the public can break things, you should be able to, yeah, not allow them to break anything. And also an interesting thing, I mean, if you're in a normal car, you can hear the engine running. In an electric car, you cannot. So if your car is in active driving mode, you have to have maybe an audible signal or an optical signal that you're leaving the car when it's still able to drive. Maybe the car will just drive off by itself. So I'm not sure how fast I was, so maybe I was a little bit faster than I was. I'm getting actually to the end of the specifics for the electric vehicle, and maybe the end of my presentation. The ADR I mentioned is a lot of large set of documents, and we're currently working on. We've been over the documents already. We're currently designing our new car. These things are just to show you like what kind of items were surprising for us for an electric car. We know about suspensions, we know about bodies. The EV regulations were a little bit harder to find, so I thought I would share that with you. Yeah, if you go into all the other items, I mean, every item of a car has a regulation, so there's a lot of work to be done. I don't know if I can leave you with a presentation, or a video of our more like a recent video. Where did you leave it there? Of our team.
Good morning, viewers, and welcome to Casey Fields in Melbourne Southeast. Recently, Andrew Simpson told me his solar car could go 100 kilometres per hour, and I thought, look at you, Science Nerd, you can't impress me. You're super slick, fast, energy efficient design. But now that I'm here, I'm pretty impressed. Andrews is the chairman of the Aurora solar car team. Aurora have competed in every World Solar Challenge since its inception, with an impressive record of 4 second placings and 1 win overall. Everyone here is a volunteer, which we love. And in 2013, the rules have changed a little.
So the time has come for a new generation of solar cars, something that the general driving public can really relate to. And so the World Solar Challenge is moving towards vehicles that have 4 wheels in new classes and have much more passenger car-like characteristics. And so we will be going in the cruiser class, and that requires room for at least 2 seats. And so this will give the cars very much a GT or a sports car look, if you will.
These 2 cars could look much more different, but really the aim of the Aurora team is to become as recognisable and familiar to all of us as your regular Commodore.
Whilst this car is a pure competition vehicle, the next car, Aurora Solaris, will be very much a car that you can register for the public road. And we intend to be the first completely solar electric road registered vehicle in Australia.
Some of the benefits of solar cars are very obvious. They're driven by the sun rather than traditional fuel. But this car also contains a whole lot of efficiency solutions that you may not have even realised.
One of the big ones is our motor. It's 98.5% efficient. Your average petrol engine is about 30 to 40% efficient. And that's a large reason why the car can perform so well with little power that it does actually have. At 100 km an hour, it actually will output more torque than the V6 Commodore.
What are some technologies that came from solar car engineers and are now used widely in regular cars?
One of the key ones that we've got are tyres supplied by Michelin. It's a low rolling resistance tyre, so that's actually available and fitted to production cars right now. You can go and buy your bit of solar car technology and bolt it to your car at home. We run our tyres at 70 psi, which is very, very high. We average about 36 or so. But yes, higher tyre pressures do save fuel. The car's fitted with what we call regenerative braking, or in the Formula 1 world it's known as KERS. What that is that the electric motor at the front works as a generator when the car is slowing down, and up to 70% of the energy that's used to accelerate a car can be recovered during the braking process. We've been using it since 1993. Formula 1 has been using it for the past 3 years. The Toyota Prius was the first major production car that had it fitted, to my knowledge. A lot of the other team members are in it for the racing, in it for the technology. We come from all walks of life. We've got tradesmen on the team. I work as a teacher. We've got engineers, students. So the whole gamut, and it's a colourful, different organisation in terms of everyone's approach, which is what makes it unique.
Everyone involved in the team is a volunteer. They're working on a shoestring budget, they're doing it in their own time, and they're doing amazing work that even a major company could struggle to do.
I'm checking the charges on the batteries, that they're all balanced, which technically means at the same voltage.
So thanks to the Aurora solar car team, I now know a street legal, fully aerodynamic, solar-powered car is right around the corner. You've been watching Ecotopia, where the future lives. Good night.
So, stop. No.
Any questions?
I was wondering, all the UN laws and the ATA laws, is there anything to say like safety wise? At the moment, cars have airbags and all this sort of. Just wondering, is that compulsory?
I've not, it's a good, airbags are, I haven't found anything about it being compulsory. It's recommended, of course, but it's not compulsory. So we might think about it. It's a very difficult system to implement in an individual constructed vehicle or a very low production vehicle. I'm not sure if does the Tesla actually have them? I'm not sure. But no, you say it doesn't. Okay.
If you look at all classic cars, they want to have one, but they'll
you will not get the 5-star NCAP rating and stuff, but I mean, it will still be able to. You're still allowed to drive it, just like you're also allowed to drive hot rods or other cars. So it's not required.
Is it possible to have a 4-seater one eventually?
Well, it is possible, yes. We don't have that on the plans at the moment. I mean, we're a volunteer team. We're not a production team like the Tesla, for example. They start with this Roadster and then get the Model S. I mean, we're thinking of like first going into a more practical direction. We push ourselves by going into the ADR as well, which is not required according to the World Solar Challenge, but we push ourselves in that direction. We want to, when we make a car like this, this car was 2007. It was capable of racing in 3 races, but now the regulations have changed. Actually, this car, when it was built in 2007 and raced in 2007 race, you could actually still lie down in the car. Then the regulations changed, and they said you have to sit, well, at a certain angle. You have to actually sit in the car. So we actually had to add this little bubble in the back, so you can actually sit down in the car. And now the regulations changed that they want to go towards a more individually constructed vehicle type. With 4 wheels. Well, we have 3 wheels. To modify this to 4 wheels would be, well, basically too complicated. So we want to go towards a car which is, well, which can last for more years than only 1 race. So going towards ADR compliance will make sure that you can race it basically forever. I say race as in because our main focus is the World Solar Challenge, but we have a lot of events such as this one and such other events where we actually showcase the technology and what is capable. What can be done with solar technology and how cars can look like in the future. And we do think that this car might actually, the next car might actually end up in maybe short scale production. I mean, who knows who want? There are always people in the world who want to buy the first solar car and own a first solar car. So who knows? Yeah, maybe.
Could you explain the cabling a little bit for me? It wasn't quite clear. You said it had to be orange.
The cabling, yeah. Yeah, they both have to be orange, which is an interesting thing because you can, well, in our case, we know red is the plus and black is the minus, and we connect the connectors together like that. But according to the regulation, any high power or high voltage cable over 60 volts has to be orange, and it doesn't matter if it's positive or negative. Well, you know, you can mark the cable, but it is indeed, like you said, a little bit more tricky to find out the exact positive and minus. You have to really make your connectors correct. and not being able because we very often disconnect and connect them again. So you have to make sure things go right.
So all cars are like that.
I think if you look in the Tesla, you see only orange cables come. Well, you don't see many of the cables, but there's a little bunch of orange cables coming out of the battery pack towards the control electronics. So yeah, exactly.
So you've always got to trace something.
In some way,
Yeah.
yeah.
Sometimes you put like a red or a green, a red or a black sleeve, cable, just so that you can remember.
Yeah.
The practice has become heat shrink sleeving over where the lug is, and you use black for the negative. And
Yeah, exactly. That's one.
so you can identify what the orange cable is. And for three-phase, it's normally red, white, red, yellow, blue.
Oh, okay, sure. Yeah, I haven't seen our three-phase is just all the same color, so because we never take the three-phase apart unless we have to take out the motor, but that doesn't really happen too often.
So you talk quite a bit about the battery having things like a shock sensor and that sort of stuff.
Yeah.
Disconnect itself and to break itself up in packs,
Mhm.
packs and other lights and stuff, and special tools. Of course, in a solar car, you've got a second source of power. That's the solar panel itself.
Yeah.
How do you think about how you structure that? Do you have to structure that in a sort of
There is no regulation for that. The regulation I mentioned, these are almost all the points I found related to electric vehicles. So it's not even that much already. There are. I read another document which mentions that for electric vehicles, they're still discussing like what other things do we need to add into the regulations.
So those rules there for battery for a reason around safety. So
Yeah.
if you're trying to bring those analogous rules into the panel, what do you have to do for the panel to make it interesting?
And we have to do a similar, probably similar techniques, at least just like your any high voltage design, you have to isolate it correctly, mark the plus and minus correctly, and make sure that things cannot be connected incorrectly, or that you can touch the wires. Or
So what sort of voltage does the panel as a whole produce?
well, the whole panel itself. That's a good question. I'm not really sure about that voltage, but it's getting into lethal voltage range as well. First, from the panels, we go to the maximum power point trackers, which then transform the panel voltages, because it also depends on how much sun you have, into the battery voltage to charge the battery. So the connection between the panel and the maximum power point trackers and the power point trackers to the battery, they're all high voltage, so that all should be taken care of. So basically extrapolating the current regulations to those systems as well, even though it's not specifically stated. You should make sure that it basically says your car has to be safe, and you should not be able to touch live wires and stuff. So just the routing of the cables throughout the car should be set that way that it's not in the cabin. Even though panels are on top of the cabin, you have to maybe get an insulation layer or get the cables on the edges of the layer where not the cabin has stopped or something. So that has to be taken into account into the design of the panel.
Do you have alarm legal experts to advise you of loophole?
No, we actually have no legal advisors at all. We can, we know some people who can assist us. We have, we might actually need to get back to one of our sponsors, which is a legal firm, to assist us with these documents. But we found that if you personally build an individually constructed vehicle, you don't need a legal team either, as long as probably Vic Rhodes agrees with your work. That's maybe more the approach we are currently taking. Of course, I don't know, if you go into production and selling the vehicle, then you have to get some legal advice, certainly. But then again, this car that we're currently designing is not the direct produced car. So there will be, this is sort of one step. Might we go for production? we'll make another one and get legal advice in developing or modifying the current car to the production car.
You also mentioned that the air conditioning is not compulsory.
No, well, if you want to produce one, that people would certainly like it, but it will certainly decrease the range of your car as well. Yeah, isn't it? Yeah. Thank you.
How far away do you believe your prototype of your new vehicle is?
Well, we're currently quite advanced in the design. The body design still needs a little bit more detailing. We try, as if we have if all our sponsors are also willing to actually get it done this year, hopefully before the Solar Challenge. But there is some discussion within the team, like is that possible? Is that not possible? That has to be thought of. But we're doing our best.
So I was going to ask, what sort of motors are you using in the vehicle, and do they drive both wheels? Is there two motors? How are the motors configured?
Yeah, at the moment we use one wheel in the front, which is a CSIRO Marant wheel. We actually, together with CSIRO, Aurora has helped develop this motor, and Marant is now starting the production of this motor. We will indeed move this single motor to 2 rear wheels.
And so it's actually producing. This is a switch reluctance motor, isn't it? The CRS.
I'm not sure the terms. Sorry.
Producing it, it's a production motor.
Yeah, I think it's a low volume production, but they are producing it, and I know other solar teams are purchasing the same one from around the world. I mean, because the weight of the car, this particular car is 140 kilo. The new car we're making is approximately 250, according to our budget. These motors cannot currently be used in current vehicles because they're just too heavy. The motor is 10 kilowatts per motor. But if this kind of technology, lightweight vehicles with the similar safety, we do like safety analysis as well. It's like a Formula 1 car in some way. You have your carbon fiber box where you're sitting in, which is like the real strong point. If that gets through to other manufacturers, then these motors can also be used for those purposes. So I think that's where Marant is looking at to get into more production in the future.
If you're seriously out that many solar cells together, what happens if you start to damage the individual cell? Do you have enough voltage across it to cook it and create a fire, or is it?
Oh no, the solar panels can be. We can add diodes to it, which are bypass diodes. So if a cell breaks, or actually the same functionality happens if there's shadow, you don't get enough. You get less power out of this one certain cell compared to the other one. Then it bypasses that cell, and it just decreases the voltage. But the PowerPoint trackers, they have a large input voltage range, and they always make sure that it is converted to the battery voltage. So that the safety is inbuilt into the panel itself for cell breakage and cell shadow. The additional safety for voltage protection is in the PowerPoint trackers.
And one question, I noticed with the solar panels, I noticed the solar cells that are mounted onto the body, how are the cells then sealed over the top?
The cells, as you can see in the car outside as well, they have a thin plastic coating. Actually, the cells are in between two layers, and then only at the edges of the cell the wires come out. So they're sort of completely sandwiched. Yeah. It's I'm not sure what the type of plastic is, but in solar panels on your roof, they're in between glass plates. So that's of course too heavy for a car like this. And you can see also you get a little little curvature out of this. Yeah, that's the advantage of this plastic.
I might power can that generate in full summer?
The panel we have currently on the car can generate about 1.2 kilowatts. So we're basically running the car at 100 kilometers per hour at the power of a toaster.
Before you say that the motor is a 10 kilowatt motor?
Yeah, 10 kilowatts. Yeah. It's the weight is a good question. Less. Yeah, it's peak. Yes, definitely. Sorry. Yeah, it's around that value. The optimal point is set at 1.8 or 2 kilowatts continuous. Yeah. Yeah, air cooled. There's no. It's 98 point. Well, like the video said, 98.45% efficient. So. That is the peak efficiency, but the spreading is between 95 and 90 and at maximum. So it's quite efficient throughout the whole range.
Roughly how many solar cells on that vehicle there, and are they a proprietary brand of cell that you buy?
Yeah, you can actually buy these cells. This is I'm not sure. I haven't counted them, but I know it's 7 square meter. So yeah, you're in the hundreds. They're
100 mil or something like that.
Yeah, they're standard solar cells. You can actually buy the same type of solar cells for your roof, except that they will then be within glass. They're from SunPower Corporation.
How much time will it take to monitor each cell?
Sorry again?
How much time will it take to monitor each cell as stipulated in the regulation?
You mean the battery cells? How much time? Well, the electronics are fast enough to be able to do that. The regulations do not state any time span, which is interesting as well. I mean, it can say so you have to monitor the battery voltage, then you drive, I don't know for how long, and oh, okay, let's measure the voltage. Yeah, I just monitored it. So that's probably another discussion where the legal people need to align with engineers to find out, like, the regulations are not too clear, and the United Nations document is actually developed in 1997, so it's pretty old. For the current developments of electrical vehicles. And the document I read is that many countries are developing their own standards, many companies are developing their own standards. There's no official EV standard for many EV particular equipment yet. So I'm not sure when that will happen, but I'm pretty sure there. Yeah, exactly. It creates a lot of confusion. Yeah, exactly. So this is what the ADR says. If you follow the UN regulations, it's good enough. Which is, well, 1997 is a pretty long time ago. There should be an effort to new regulations, I suppose, especially when many new electric cars come out.
So how efficient has the solar cells become since first?
The first car, oh, that's a good question. I think the first car, 1987, you mean? That one was probably around 12-15% efficiency in silicon cells. These ones on this car are 22.5% efficient. The new car we'll have is 23.5. So between 2007 and now, basically, there's only a 1% point different. Over many years, there's a large difference. Sorry? The theoretical, I must mention that the theoretical maximum for silicon cells is, I think, 33. So the closer you get to that maximum, the slower the development is, because the harder it is to actually get there. The same with the electric motor. If the first motor was 97% efficient and took a lot of effort to get to 98.5, so it's just that very tiny improvement because you're getting to the maximum.
End the session there.
Okay, thank you all.